So it is my pleasure today to introduce Dr. Jenna Jambeck. Dr. Jambeck is the Georgia Athletic Association Distinguished Professor in Environmental Engineering at the University of Georgia. She received her degrees from the University of Florida, bachelor's, master's, and PhD, all in environmental engineering. She has won a host of awards. She's a MacArthur Fellow. She's a National Geographic Explorer. She led the National Geographic Sea to Source expedition for the Ganges and currently leads the science program for the Mississippi River Plastic Pollution Initiative. She has been recognized by global community. She's testified to Congress and G7 and G20 declarations and the United Nations Environment Program. In other words, she's somebody that makes a difference both locally as well as globally, and we're very excited to have her here. She's also the host of a podcast on NPR, right? Which is a really good thing if you think about as students out there, how do you convince the broader world of what you do? There's a lot of different ways to connect with that. So with that, please help me welcome Dr. Jambeck to the stage for a presentation.
Good morning, everyone. It's really nice to be here. Can everybody hear me? All good? All right. Let's jump in. It's really an honor to be here when I was invited. Just a historic engineering university. It's really my honor to be here. And to start off my talk, I really like to acknowledge the group that I work with every day. I have an incredible group. I actually have quite a few staff besides students, full-time staff that I work with. One of my staff members started off her first year of engineering working with me, and she's still working with me to this day after she's gotten her master's, and so that's really meaningful. I currently have 3 PhD students working on many of the projects that you see here. The other folks I want to acknowledge are all the people that I've met and worked with around the world, all my collaborators, and then last, but definitely not least, my family. My husband and I met doing research together. We met at the landfill. It was a very romantic setting, and brought our kids back there. Our boys are 17 and 14 now, so they're much older than you see in this picture, but we brought them back to the landfill where we met. They were not impressed, for sure. So I'm here today really to talk about my research focus, but I want to start with some context about plastic. And, this material, which we use daily, probably can't imagine our lives without it now, did not really come onto the scene until the 1950s. That's really when we actually started measuring the quantity that we were producing. And by 2015, we had produced, for use, 8.3 billion metric tons, really an impossible number to imagine. So we tried to equate that to a few things, but they're not even possible to imagine to me. I can't imagine 80 million blue whales even. So the thing about plastics, though, a lot of the plastics that we use are 40% of them are produced for packaging specifically. So a lot of them enter the waste stream very quickly. So at the same time that we had produced 8.3 billion metric tons, 6.3 billion had already become waste that we've had to manage. Both of those numbers projected to grow and have grown. This was research that we did after our 2015 paper. So this came out in about 2017. So one thing I wanted to kind of step back to that when I first started working on plastics didn't sort of click for me. So I sort of like to go to this now, is that fossil fuels, so crude oil, as well as natural gas, are the feedstocks of plastics. And really understanding that we're making all kinds of products out of those materials, especially crude oil. And so the building blocks of plastics are just one component of that. So it's part of a whole system that is doing many other things. And that's why it's sort of like this whole train. I kind of think of it as a train that you can't really stop going down the tracks, right? It's a part of this whole system. And I think just that one monomer, so ethylene, makes all these different plastics, and really kind of understanding the usefulness and why this material is so heavily utilized, and inexpensively and efficiently through these processes. It was really a byproduct at first of these refining processes. And this is still continuing to grow, right? Especially because some of those other fossil fuel uses maybe are starting to slow down. The petrochemical and the oil industry is looking at expanding the use into plastics because the demand for those continue to grow. The other component of this is not only are polymers and plastics being created from that, but other chemicals. So ethylene glycol, for example, is also created, but there's only so much of that we need. So you have this excess ethylene that you can polymerize and create into a plastic that can be used sort of at a later date, right? So we do need some of these specialty chemicals as well. So plastics are just a part of the system where it becomes very, very easy to use them. And I think of them in terms of like green engineering. Instead of always having a need for this specific material, it's like we have a lot of this material, what can we use it for? Which is not necessarily the best way to utilize a material where you're looking for uses. You really want to have a need and have a specific material that serves that need. And that is how we end up with some of the problems that we see with plastics today. Our waste management systems have not been able to keep up with the production and use of plastics. So they have leaked out into our environment. In the 1960s was the first time that they were found by the U.S. Fish and Wildlife in birds, ingested plastics, and then they were continue to be found all throughout the oceans. This is a compilation of various studies, including our study from 2015 that showed the leakage of plastic from land into the ocean. Rivers were also shown to be a conduit, and then the pink circles here are the different concentrations of microplastics found floating in the ocean. This is what fragmented plastics look like. You can see some of the items here. So this plastic is what we found before we crossed the ocean. So in 2014, I crossed the ocean with 13 other women in a 72-foot sailboat from the Canary Islands, and we collected this in the Canary Islands before we sailed. I had not really ever been on a sailboat. I think I'd been on like a tiny sunfish, like just off the coast. So this was quite the adventure for me. We were on the sea for 19 days, and we did everything. We sailed the boat and collected data at the same time, but it was hugely impactful. Before we set sail, we did a beach cleanup, and I walked up to the edge of the ocean, and I was just kind of looking out, going, okay, I'm going to be crossing you, ocean, please be nice. And I looked down, and the waves were crashing up, and they were just filled with the confetti of plastic. And it just hit me at that moment. I had been doing, as an environmental engineer, most of my work on land, creating systems to prevent that. But I was like, the oceans are literally spitting this material back out at us, saying, it's just not supposed to be here. So that was hugely impactful for me to continue to sort of dedicate my mission to understanding and hopefully preventing this plastic from getting into the environment. The other thing that I think right now is happening with microplastics specifically is a lot of people are studying not just the environmental implications, but the human health implications. This is sort of the cutting edge of this research, and I think has the potential to get companies and systems to change. Once we start to understand how this might be impacting us directly, that tends to motivate people a bit more than our environment and animals, unfortunately, but that is the case. So after we published that 2015 paper, we wanted to also sort of look at our own backyard. So the 2015 paper was a very global paper and led to a lot of looking around at other places. But we really wanted to say, what is the U.S. contribution? And although we do have a very robust waste management system here, we still have things that leak out, especially a small percentage of leakage with a high percentage of waste generation. We are the highest waste generators per capita in the world. Leads to quite a bit of leakage itself. Also, export of materials for management in other places where they may be mismanaged can contribute to our own contribution. So what, another study that I was a part of, which was a parallel study with a Pew study as well. And this was a significant moment for me in my career after 2015. This 2020 cover of Science saying plastic pollution because when I first started in this field, first of all, this was known as marine debris. There was no focus on plastic. It wasn't even a scientific discipline, right? So the fact that after I started looking at this issue in 2001, just by 2020 alone, this had become an issue with enough science to be the cover of Science magazine. So these two parallel studies in this issue both showed that we could not keep up with waste management to bend the curve of plastic entering our oceans just by waste management alone. So this sort of downstream action really could never be enough. We couldn't keep up with this generation of plastic waste. We needed to change things upstream. And these were two independent parallel studies, so to me that was very significant. So when I first got asked to testify to Congress, it was not too long after 2015, so it was 2016, the first Senate testimony. I thought about that paper and how we calculated the contribution of plastic and how it entered the ocean. And I thought, well, let's just step back and see how we can prevent at each stage, reduce the quantity that's there. And that would be then capturing it before it enters the ocean, reducing the amount of waste that's generated in the first place. Are there alternatives we can use? And also use less initially. So that came up with this strategic intervention framework. And then when I got invited to be a part of the National Academy's consensus study on looking at the U.S. contribution to plastic pollution, we ended up using this strategic intervention to talk about where you can intervene to reduce. Now, it's not a single intervention at all. This is an all of the above situation, but it does make sense. The more upstream you intervene, you don't need to put resources later downstream. And so this has led to my current work, which is a lot of community-based work. And as an environmental engineer, I was working on a lot of these global models. And then another opportunity came to me. So after the 2015 paper came out, the U.S. State Department called me in, and this was an interesting scenario because it's kind of one of those situations where you're like, how did I get here? I'm in a tiny room at the State Department, and they're quizzing me about my paper that had come out, and it was at least an hour-long meeting, very amazing, and a lot of detailed questions. And I think they were just really trying to figure out, did I know my stuff? After that, I was invited to do these public environmental diplomacy programs around the world. And so they were incredible. I was getting to see many of the countries where plastic pollution had sort of overtaken, waste management systems were lagging and trying to keep up. And so as a part of that, I would talk about sort of the issue, and then they would say to me, Many of these were communities, as well as other event spaces. They would say, okay, Jenna, great. Now we know about this. What should we do about it? And I was a little taken aback because I was like, I've been here sometimes maybe 12 hours. Before I talked to them, I thought, I don't know that much about this place. You are the expert of your own location, your country, your culture, your all of that, your context. But what I was seeing was a lack of data. So there wasn't a lot of localized data to say, well, should we ban a certain item? Should we put in a reusable foodware system? Should we put in a river catchment device? And that's what they were sort of asking. And also, as I landed in these places, I would look around sort of instantly. I think my brain is quite unique in that when I land somewhere, I immediately look at the trash cans, look at the signage, see what I see on the ground, see what's for sale in stores, and traveling to all these places really illustrated all of these differences to me. And I thought, well, can we systematically design where we're collecting this data around the world? And that's how we came up with this circularity assessment protocol. So it's a hub and spoke model. There's 7 components. And what's different than other frameworks that just study waste management is we do look at what comes into a community, what is for sale in the stores. I think that very, very much matters, right? Because you can only purchase what's available. And so I think that's really critical, that it's more of this holistic picture all the way to what ends up leaking out of the system into the environment. Some of these drivers, if you think about it, so policy, governance, economics. If you think about a plastic bag ban, so for example, if you look at these components, so at input, if there's a ban on plastic bags, we shouldn't see them in the stores. We should see community members being aware that these bans are in place, that they need to bring a reusable bag. We'll see bags made of other materials. We will see reusable bag systems. We won't see them in the collection stream. We won't see them need to be managed in the waste stream. And then hopefully we will see none or less of them in leakage if it's well implemented. So that's one example. So we've really had the honor and just great collaborations all around the world to be able to do CAP in more than 15 countries and more than 60 cities all around the world. And we work with local implementation partners. At first, we were doing the field work in collaboration with folks, and actually this was sort of just taking off as COVID started. So there was a challenge there, and we ultimately were going to get to this model where we trained local partners to conduct the field work, but that pushed us to immediately do that. And people were very much more open at that time to being trained over Zoom remotely, and so we were able to pivot to that immediately, which is what the model that we wanted to do anyway. And so that was just really great because local people understand that context and culture of their city and can become champions of the data as well and build their own capacity with learning all of these systematic methods that we had developed. So these are some of the projects that we've had that have been various collaborators, various programs like the Urban Ocean program with various partners. We've had some work with the Walmart Foundation and worked with the Mississippi River Cities and Towns Initiative as well. An organization called Perpetual that looks at putting in foodware reuse systems. I'll talk more about our NSF project, which is our most significant project right now. And then we've had the honor of working with a few different governments around the world. So this is one of my favorite things to talk about. So this tool, we use it in the Circularity Assessment Protocol, but this is an app that we developed at UGA and was released in 2011. It started when I was at the University of New Hampshire, which is where I was at before the University of Georgia. And actually, the idea for it started even back when I was at Florida. I'll never forget when I went to visit the Center for Marine Conservation, which is now Ocean Conservancy, their headquarters, and they were working with community members to collect data with the International Coastal Cleanup, which is still going on now, every year. And I was in the office, and the data cards were like piled up like 2 feet high all around this office. And I just thought, that's not very actionable data, because then the data would come out after a year and then they do another cleanup. And I thought, well, wouldn't it make sense to be able to have that data in an electronic form sooner, to be able to look and see, what are the top items? And I mean, to me, every item that's found is like a clue, right? Why is it here? I have 3 questions later. Anyway, so that was just even getting GPS coordinates and getting data in electronically. And the first iteration of this I made on a personal digital assistant, or a PDA, which, yes, people of a certain age definitely know. So those were like smartphones that didn't have wireless, right? So there was a program called Pendragon where I could make my own form. So I took paper data card, put it in there. My students would take it out, collect data, bring it back to my office, and you had to put it in a cradle connected to my computer for me to get the data. So when smartphones came out, yes, the saying there should be an app for that was very obvious. I had a computer systems colleague, and that's one of the cool things about the program at UGA, is that we were all in one building at first. So I was running into every kind of discipline engineer. So I ran into my computer systems colleague in the hall, and I said, hey, if 1 million people told me they found a cigarette butt around the world at the same time, would I crash our servers? And he was like, what? Why would anyone do that? And I was like, well, I have this idea. I want to create an app. And he's like, oh, that'd be fine. So I wrote it into the grant, and then I got the grant, and I was like, hey, Kyle, do you want to build that app I was telling you about? And he's like, sure. So he helped me develop this app, Marine Debris Tracker, which has been out now since 2011. You can find it in the Apple and Android store. But we have, in over 90 countries, people have reported over 10 million items through this system. We use it ourselves for research. The data is 100% open. And this was something that I was very adamant about when I was creating something where people would be using it to collect data, as well as just, my age. Again, I've been around since the internet started. And I remember being a researcher and finding, someone talking about data on the internet, but never really seeing the data, right? It was very rare to have raw data be available. And I just think it's so powerful to be able to do that. And so we dedicated to having this data be open and 100% free since the inception of the app. And so you can still find it there at debristracker.org. Many organizations around the world use the app, and it's amazing. It's about 1 million items that are reported every year now, but at first it was like maybe one a week or something. I was like, oh, maybe someone will tell us once a week. It's now like 2,000 items a day all around the world. We have published on the development of the app, as well as there's been many papers now, and papers even beyond where we collaborate, where people have used this app to collect data to address things scientifically. We also have now published some of our circularity assessment protocol data. What I'm really proud of with many of these papers, actually all of these papers that I'm going to show you, is that our local implementation partners are a part of these papers. And I think it's, again, so important they have that local knowledge, that context, that, local community level engagement that is so important to, pushing this data forward if they want to use it. In some cases, they might be like, things are going well. That's the one thing about a CAP I want to talk about. It's kind of like going to the doctor for your annual physical, and you assess things, maybe your blood pressure, your cholesterol and things, and you might find, hey, your cholesterol's awesome. It's going great. So there's one component, there's things going fine. Whatever you're doing there, keep doing it. But your blood pressure's kind of high. And then you talk to your doctor about, what would you like to do? Would you like to change your diet, change your exercise, maybe take medication? You have various choices that you can do. And again, it's sort of up to you. That's kind of what the CAP is like. It's up to the community if they consider something that they want to do something about, they want to intervene, what do they want to do that fits with their system. So this journal also, you have to have community engagement and collaboration, not just engagement, I should say, actual collaboration to be able to publish in this journal. So again, I think that makes me really proud. And this one is the Urban Ocean Project. So again, all of our different local implementation partners and just many of our partners are able to contribute to these publications. And I think I didn't finish my story on the pivot to the community work. And I want to do that now. I want to circle back because, so as people were saying, what should we do? I was also thinking about my roots in environmental engineering and really seeing where the burden of waste management lies, right? There's all these global decisions, and I was working on these global models and, talking to, interfacing with the G7 and G20 and thinking about, yes, that's all important at that level, but the day-to-day burden and use and in sort of engagement with plastic and plastic waste is in our communities. And that's why I really wanted to conduct work at that scale. And we have been able to work in our own backyard. So I think that's also important. We are the land grant institution in Georgia and also serving that state. And so being able to work with Athens and UGA itself, we're currently conducting a CAP on the campus itself, which has been really interesting as well. So our methods were developed through some of my work with National Geographic, so I wanted to tell a couple stories from this. So this work was done in 2019. We had a lot of preparation through 2018, but we had a team of about 18 people all at the same time, different people coming and going. I co-led this expedition with Heather Coldaway. We traveled the length of the Ganges River all the way from Bangladesh through into the mountains of India twice that year. And it was an incredible opportunity to collaborate with local community members as well as other institutions from the UK. And out of that, we had 6 publications. And again, we published our methods openly. Again, a very important thing for me in this process is to make these methods and as much of the data, again, if we use Debris Tracker for a lot of our data collection, completely open and available. After I came back from that river expedition, that unfortunately ended right when COVID was starting. So thank goodness we were able to finish that whole work. And but I think the follow-up got cut a little short because of COVID. But this is when the Mississippi River Cities and Towns Initiative were working on their plastic pollution initiative, and they reached out and said, can you design a data collection system kind of like the Ganges, but you won't have a research team. We want to use our community members to collect the data. Not something that I would ever dictate. I, as community members, we all are pretty well burdened, but it actually was perfect timing with sort of the ending of COVID where people wanted to get outside, make a difference. The mayors were literally talking to their community members and encouraging them to collect this data. and talking to them about why it was important for their community. So we did. We designed a way that we could train community members. They could figure out how to do transects. So our methods of collecting data for leakage are walking at least 100 meters and counting every item in 1 meter width. And so we were able to instruct people on how to do that and make a map where squares would turn colors if enough data had been collected in a 1 kilometer square, so that we didn't have everyone, for example, St. Louis was one of the cities, everyone would probably just go to the Arch Park and collect data. So we tried to get people spread out. And it worked. And then the other thing ended up being one of my favorite expeditions, was because this was kind of at the tail end of COVID. I ended up bringing my family on it because it was community members that were helping collect the data. So I was like, wait, why not? Why not my family? So we traveled the entire length of the Mississippi in this camper, which my kids end up calling the Cramper. I don't think you could get my 17-year-old back in this camper again, but especially now with how tall he is. But it was amazing because, I'd had to leave my family for so many of these trips and travels and everything that I talked about. So to be able to, I didn't have 18 people, but I had 3 people who were pretty dedicated. And so that was great. And then, of course, all the community members and all our stopovers. So people did do this. They collected data. Like I said, I think it was the right time for that, for people to get back outside and want to do something. And this is what I was talking about earlier when I said I see these items as kind of clues. And I think these 3 very simple questions kind of lead us to potential interventions, potentially asking, what can we do? So that's why we asked very specifically for data on what this item is. So what is it? And then you sort of imagine, well, how did it get here? What's the scenario? And again, this is where local knowledge and context is so important. And then if you think something should be done about it as a community, what should we do about it? We meaning local folks. And that doesn't mean all solutions are local. Of course, changing the system is important as well, which I'll talk about. Okay, so looking at what was found, so the number 1 item in the Mississippi River Basin, so we had over 136,000 items logged, were cigarette butts, and that was followed by food wrappers and beverage bottles, technically recyclable items. I think aluminum cans are up there, as well. Not in the top 5, but they're right there. A lot of cups, especially in the southern Mississippi where it's warmer. But yeah, so over 185 kilometers squared, which is over 30,000 football fields, were surveyed by community members. So it's pretty amazing. And litter's costly. So just cigarette butts alone, an estimate has been made that this costs $26 billion per year. We were also asked to do some brand auditing, so we had a few people note what brands were found within the litter, and so you can see, I think companies that make especially both chip brands and drink brands tend to be found more frequently, but I think this has brought about a lot of questions for responsibility. And because of this, we've seen some lawsuits now. I never did expect, now our data was not used in any of these lawsuits, but definitely this kind of data has been used in lawsuits. And that was fairly unexpected in terms of me thinking about collecting this data in the first place. But I can tell you that it's been an interesting scenario here. So this was a lawsuit brought by the New York Attorney General. Then this was dismissed. But just before that, LA County brought a lawsuit. So we're seeing this start to show up in the courts. And then not only consumer goods companies were those, you can see that California Attorney General has also brought a suit against ExxonMobil. which then ExxonMobil sued back. So this is, I think if you don't see regulation, and this is great, I think the panel is going to be really good. If you can stay for the panel, I met my panelists this morning and we were even talking about, and remember from that CAP diagram I showed you, policy is in there. In a space without regulation, you're going to see this issue end up in the courts, right? I think that happens. So another thing that we were able to do with our data is the US EPA came knocking and said, wow, we see that you have all this, systematically collected leakage data. They call this escape trash around the US. Do you think you could tell us where we probably would find that based upon all this data, empirical data you've collected? So we said, well, let's see. I mean, we do have quite a bit, but we need to collect a little more. So we collected a little more in every single river basin all over across the U.S., including Alaska and Hawaii. Some of that we already had. And we were able to create what's called this escape trash risk map. So it's not a model saying this is what you'll find. It's sort of like a risk of what you might find. So you want to then look locally to confirm. And I can say that we have done that. One of the places most recently, and we'll be publishing this soon, is in LA County, which the empirical data we collected based upon the risk map matched the risk map. So I always, wherever I'm going to give a talk, I always zoom into the location. So this is even more, Lafayette and West Lafayette. And not very, well, I don't know. My last place I was giving a talk was New York City, so the picture looked very different. But the drivers of this, just so you know, that I need to tell you that, are the Human Development Index, which is income, life expectancy, and education. Those three indices combined, and then high intensity development. So that's what we found correlated with the litter quantity or the litter densities that we were seeing, and how this risk map was developed. It's basically a model. Interestingly enough, we also use to stratify our data collection, a data set called LandScan. And LandScan is a prediction of the human activity in a 1 kilometer square over a 24-hour period. And interestingly enough, this data set is both correlative to increased litter density, because you think more people, more waste, more litter. But the other thing that happens, if you know about infrastructure, is more people, more infrastructure. So the more people that are in an area, I don't know, maybe a shopping mall, there tend to be more trash cans, maybe more cleanup, maybe it's touristy. So we actually, in some cases where there's more societal activity, will see less leakage because of those cleaning activities. So it's not just more people, more litter. So that variable is not a predictor in this model, but we do look at it to compare our data once we've collected it, and we use it to stratify. So regulation, we don't have any federal regulations related to this specifically, and I'm specifically talking about sort of this upstream addressing plastic pollution, but we do have some state regulations, and so I wanted to bring up this extended producer responsibility. This has been passed in 7 different states, and what it does bring back some of the responsibility for use of materials. This is specifically for packaging. Some of them are related specifically to plastic, some are not. Recyclability, so they're saying if you're going to use a material, maybe it has to be recyclable, or if you use plastics, maybe you'll have to pay more in taxes, and all of this money can go to fund our waste management systems, because again, as I said, the burden being at the local level, people need help in managing this packaging materials that the companies who are using the packaging are able to use without that burden. So shifting some of that, at least economic burden, to some of the companies. And so that can produce something called eco-modulation, which means they will change their packaging because of these regulations, right? So if there was a tax on plastics in one of these EPR states, then you maybe would say, okay, well, it's worth my time then to invest in a different material, so I don't have to pay that tax. And so that means your packaging will change because of these. Okay, so now I'm going to jump into talking a little bit more specifically about our National Science Foundation project. So this is a convergence accelerator project, and I had applied, I don't know how many times, multiple times for NSF funding before this point, and always been rejected. I never changed what I did, but NSF changed. And these solicitations were like a perfect fit for a circularity assessment protocol in terms of sort of an existing program that could be accelerated and expanded. And this program has been absolutely amazing for our work. And I'm just really, really grateful for the opportunity to expand what we're doing, to be able to scale it and involve many partners throughout the U.S. So starting with communities, and community members have a right to optimize their own circularity. We really hope to take this CAP data and provide a platform for communities to talk to each other, to share information, lessons learned, to be able to have, again, that data is power, and, to have access to that, to be able to make decisions, and hopefully create a systems change from the ground up. And so, again, I talked about open data before, but I think data is quite powerful when it's open. So looking to have our data in a system that people can access it through all of those different spokes, through all of the different communities, being able to filter by location, rural versus urban, to look at all the different charts of where products are coming from into communities, how they're packaged, the leakage component. Something interesting to note about this leakage, it's very much, any of you that have worked in microcontaminants, soil science, things like that, these histograms of the concentrations are right skewed. So they're mostly low concentrations, with the tail sort of, some of them being in the higher, but very much kind of low, with the average around 1. So that's 1 item per meter squared, is our typical average of what we find for litter. And this is all litter items. We don't collect just plastic data, and you probably noticed that with the Mississippi River data, because you want to know what percentage of all of those items are plastic. And as you're looking at alternatives that may be utilized instead of plastic, do they also end up in the environment? I think when we see single-use items, single-use plastic items replaced with another single-use item, sometimes it's littered. It can be littered just as frequently. And also the leakage from these systems, which I prefer. I like the escape trash term. I like leakage because it's much more about the total system than an individual choice. Obviously, our individual choices matter, and they make quite a difference. And when you have that collective action of just making the choice of being able to have access to clean water, so you can use a reusable water bottle, all of that makes a difference. But I do really feel like a lot of what we're seeing in terms of this contamination is very systemic related. One thing I didn't mention is that the methods are mixed methods. So I have an environmental anthropologist on staff. She's director of our qualitative research. So one spoke of the CAP is completely qualitative. So you have interviews and thematic analysis that go into that, that provides a lot of data to the community as well. So one thing that came out of this NSF project, which was really cool, was a suggestion to take our 70-page reports from all of our different CAPs around the world and to train a large language model. And so we were able to take offline LLM and put it on our own servers and feed it all of our CAP reports. And so now we will have a way for people to interact and ask questions to get sort of answers in real time from this AI LLM. And impactful. So I think data is quite powerful if it can be impactful. So if you have maybe, this is not a judgment if you don't, but maybe you have a memory in your life of where either you were trying to recycle something or why you do recycle or why maybe you notice litter or maybe pick up litter if you see it. So for example, I used to walk with my mom and pick up litter. I think we have sometimes these core memories. Another thing that I used to think of is why do I carry an item that's recyclable until I find recycle bin? Like it's so hard if I can't find one to actually throw away something that I know is recyclable, and or the litter collection. So what makes me choose to do that and then other people not? And I think sometimes we have some of these core memories. So we're looking at using virtual reality to be able to put someone in somebody else's shoes to have an experience where you were maybe limited with choosing an alternative to plastic. Because many times you might hear people say, well, just don't choose it. Like, just don't choose plastic. But it's not so easy. And I think all of us that are, grocery shopping every day know this, right? And maybe there's alternatives, but they're quite expensive. And so I think having decision makers and leaders within companies sort of realize these scenarios that we are all exposed to can help change the system. So we're creating these VR environments so that people can have some of those experiences and maybe realize the change that's needed. And then talking about scaling. So because of this project, we've been able to put our live Zoom trainings into a training portal. So similar to probably you guys have something like Canvas here, we're able to put our training into an interactive course model. And so people can take the whole course to learn the field methods that they've been conducting for the CAP around the world. So we've got videos and little quizzes and, working to make this interactive, and we're getting feedback from partners to improve this, but really trying to be able to make this more available and scalable through this Convergence Accelerator program. When thinking about the big picture of this issue, to me, I go to a lot of, workshops where we have discussions, and I think a lot of people are like, but we haven't solved this yet. And to me, as I talked about the development of this science in just, 25 years, it's been lightning fast. So I've seen tons of change over 25 years, and I'm super optimistic about the next stage. But instead of thinking about how do we solve this, I think, especially as engineers, and any discipline can work on this issue. If you think about all of the integration, it's so interdisciplinary. I think we should think about how to expand what's possible, right? Because then the system can change. Because if we sort of narrowly think about it, then you kind of just keep doing the same thing. But if we can get new materials, new inventions, new opportunities, new ways of looking at it, so you can expand the space of what's possible, then I think the system will grow and change to fill that space. And then working together will create that change. So speaking of making the space bigger. We got a new grant pretty recently. Catherine Youngblood on my team, who is our director of community science, is running this grant. We got a grant to create Debris Tracker Junior. So right now, Debris Tracker exists, and that's where we've had the 10 million reports from around the world. But this is an amazing opportunity to create a kids version, which will get kids involved with games and hopefully becoming more aware of this issue, but maybe leading into data collection. We've done focus groups and worked with kids and what they really wanted to do. Their favorite of all the different games that we thought might be good was GeoGuessr. So they're going to look at an actual piece of litter that we have found somewhere in the world and then guess where it is. And this is a really popular game already online. And so this might lead to them actually thinking about this issue more and actually wanting to collect real data within the future. And we have an incredible graphic designer making all kinds of cool graphics for that as well. If you want to dive a little deeper, although this book is a very easy read, this is a little pocket primer book that Amari Walker Franklin asked me to join her in writing. She was the first author invited by MIT Press. But this is a great little primer on plastics. Excuse me. If you're interested, I just always like to do that because she's an incredible young upcoming environmental engineer. She works at RTI now, early career. And you did hear about the podcast at the beginning, so another place to hear more, especially from our partners. We talked to a lot of our incredible partners around the world in the Aquathread episodes, which are available through WUGA, so our local NPR station at the University of Georgia. But there's some incredible folks that we got to talk to associated with that. And my young early career colleagues are co-hosts as well. And so with that, I just want to thank everyone for listening to my stories in science, and I welcome some questions and discussions. Thank you.
Okay. Okay. So we have time for a couple of questions before we...
Yeah, I guess I went a little long,
That's
sorry.
okay. That's okay. So we'll get you with the mic. So we'll start there in the back.
I'll try to be fast with my answers.
Is it on? Okay. You're on.
Hi, excellent talk, amazing information. You mentioned early on that human health implications
Yep.
might be a big driver for change.
Yes.
And I wondered if you've done anything with sort of evaluating the impact on health of the various debris that you're either human health or wildlife health or ecosystem health as part of a additional piece of evaluation for your systems.
We don't, I mean, a lot of that has been documented. So I reference, in terms of ecosystem and animal health, millions of seabirds. I mean, all of that has been really well documented by others, many marine biologists within the ocean. But some of the land-based stuff is new. Some of the grazing mammals that consume plastics and stuff, that's a little new. But we definitely reference all that. The human health is not my field, way, way, way outside of what I would have the capability of doing. I understand it, but, and even some of the analytical methods, maybe we'll get into that on the panel, can be challenging. So our New Materials Institute does some of that. I've collaborated with them some, but mostly that's with collaborators or I reference others. It's the cutting edge. And so I do think that's what can create change, but it's not what I do, but hopefully we can, that will drive the system change that I'm trying to create. Thank you.
Okay, we had a student here. Mike's coming. Just hang on.
Hi.
Hi.
My question is more regarding like recycling of plastic in the U.S.
Yep.
So why does the U.S. not have, a really developed recycling industry as opposed to other countries like in Europe and in Asia? And how should the U.S. approach actually building that infrastructure?
Yep. So that's a great question. I think the fast question with how is that those EPR laws that I talked about, we have very low landfill tipping fees, so it's less expensive to landfill it. The virgin material, as I showed at the beginning in terms of how that's created, is typically less expensive than the recycled plastics because they have the transport and processing and the other. In Europe, you typically have regulations that drive their recycling systems. In Southeast Asia, you have a huge informal sector and a very different economic system that drives those high recycling rates as well. And so we suffer sort of from no regulation and then a very low landfill tipping fee. So that EPR will help a lot. And some of the companies now that have required, post-consumer, so PCR post-consumer recycled content. So those requirements can also help drive the economics and drive the system that way. The other thing we've seen, 40% less leakage of beverage bottles where you have a deposit return scheme. So every time I've testified and they're like, oh, how do we start? And I'm like, if it's worth something, it's not going to go, into the landfill. So those deposit return schemes are kind of a no-brainer in terms of reducing leakage and increasing recycling. Those are my ideas.
Thank you.
And one last question before we fill up.
Right, great. Thank you. Fascinating talk. So I'm from Varanasi, which is one of the
Oh, yeah.
cities at the Ganges.
You're right.
Yes.
Yeah, been there
I
many times.
Yeah, very excited to see that work. And when I was in high school, we used to go to the Ganges Ghat and collect these plastics which would go in incineration. So I'm really curious what's changed. This is 1990s when
Sure.
I used to be a high school student there. And now in 2000s, what's changed? What was your learning across that Ganges stretch? And the third question which you asked, like what can we do with it? What are people telling in those cities along those Ganges to do? I'm just curious. Yeah.
So a lot of challenges there with infrastructure and the number of people. The informal sector is still very, very active along the Ganges River, which is great, which means there is high recycling, very manual, still very, manual, like people hand cutting labels off of bottles. Even some of the, and I think it was maybe Varanasi, where there was also like a food waste digester experiment going on, which was very cool. So also outside of Patna, where we went, there was a whole zero waste community, which was really great. And they were recycling everything and composting food waste, and then were just storing food wrappers in a building until I think those were getting combusted in a cement kiln scenario. So we had like little pockets of projects, but also just a lot of areas that still did not have designed landfill scenarios. So the recycling was happening sort of hyper locally, but then still a lot of leakage with disposal and things that were lacking in value to be manually recycled. So still a lot of leakage of those into the environment. So I don't know how that compares. And then Varanasi specifically with many of the rituals, the flowers, there was looking at kind of changing some of that over and not using plastic. A lot of reuse too of different jugs. People are collecting water from the river, so a lot of different things are being reused for that. So it was fascinating. So I don't know how that compares necessarily, but people are definitely, I think, thinking more and more about it, but getting the infrastructure, I guess, just figuring out how to get it developed in a way that meets everyone's needs is still an obstacle or a challenge. Yeah.
Okay. Well, I would like to thank Dr. Jambeck again, and we have a small presentation, token of our appreciation, which hopefully will not suffer any leakage.
Thank you.
And John, if you could step
Okay.
this way,
Okay.
so you're not behind the podium.
Okay.
Thank you. So we're going to break for a few minutes, switch up the stage, bring out some chairs. Don't go too far, and see you back in a bit.